So Charles' law is not the answer, as Charles' law states that as volume increases of a gas, so does the temperature, which not what the question is asking. Boyle's law states that as pressure of a gas increases, so does the volume, which also not it. Hess's law states that despite multiple stages or steps of a reaction, the total enthalpy of the reaction is the sum of all the changes, which not it. And Henry's law, which states that the solubility of a gas is proportional to the partial pressure of the gas above the solution, making this one the correct answer. So this basically means that if we were to have a container of H2O and CO2, which is carbon dioxide and H2O, and water, then if we were to increase the pressure of CO2, more CO2 will be able to dissolve in the H2O. Now, the formula for this is C equals Kp. C is equal to the concentration of the dissolved gas in the solution, K is Henry's constant, and P is the partial pressure of the gas.
What we're going to do is we're going to convert this to base 10 first, and then we're going to convert it to base 9 from there. And for our second method, we're going to use this little trick that will let us convert it directly from base 3 to base 81. So after you finish labeling these, you can just multiply each number by the value above it, and that'll give you 3 to the power of 5, 243, and so on. We're going to add this to 2 to the 81, plus 3 to the 3, 27, plus 0, plus 3, plus 1. And all this is just going to add up to 436, which is going to be our number in base 10. So from here, if we want to convert it to base 9, we can take the number 9 and just raise it to progressively larger powers, just like we did up here. And we're going to stop once we get to a number larger than 436, which is going to be 9 cubed, which is 729. We can just disregard this and start with 81. We want to know how many times each number fits into 436, so we can start by dividing 436 by 81, and this will give us 5 with a remainder of 31. So we'll take this 5 and just write it down here, and then we take the 31, move it over here, and divide it by the next number, 9. And this is going to give us 3 with a remainder of 4. And we'll take the 3, move it down here. And then the 4 we're just going to divide by 1, and then that'll give us another 4. And this is going to be our number in base 9. So that's 534 in base 9. So we have ourselves a circuit here with 2 batteries and current running in these directions because it'll go from the negative to positive terminal of the larger battery of the 2. So from here we can use Kirchhoff's current law or junction rule, which tells us that the current into a junction is equal to the sum of the currents out of a junction, which we can rewrite as I1 equals I2 and 3 added together. And from here we can rewrite Ohm's law to get I equals V over R and replace each current with its equivalent in terms of voltage and resistance. So this will tell us that voltage 1 over resistance 1 equals voltage 2 over resistance 2, and so on. And now since we're trying to solve for voltage O here, we can rewrite each voltage here in terms of voltage O, and the resistances are actually already given. So we can first just fill in the given values for resistance. Resistance 1 is going to be 3 ohms, 2 and 3 are going to be 6 ohms each. And then voltage 1 is going to be the voltage running through this resistor here, which we can define as the voltage before the resistor. which is 36 volts, minus the voltage after the resistor, which is going to be voltage O. So we can replace this with 36 minus voltage O. And then voltage 2 is going to be the current, the voltage running through this resistor. And since voltage doesn't get split at a junction the same way current does, we know that this is just going to be voltage O. Voltage O is going to run through that resistor. So we can replace this with just voltage O. And then voltage 3, even though voltage doesn't get split along the wire, we have a battery pushing voltage in the other direction. So we have to account for that. So this is going to be voltage O, just like this other wire, minus 6 volts. And then we can just multiply each side by 6, and that will give us 72 minus 2 VO equals VO plus VO minus 6. And then we can solve from here. This will give us 4 VO on this side equals 72 plus 6, which is going to equal 78. And then 78 divided by 4 is going to give us 19.5 volts. And that will be our answer A.
So the first visible thing that we can see is the very visible brushstrokes, especially in the clouds, the parasol, her dress, and the grass. Additionally, this is also a very unusual angle. Instead of looking straight up onto the subject matter, it's more of a down below, underneath view on them, which is not a very common perspective in artwork. Additionally, there is movement in this grass. You can see the grass is moving. You can see Madame Monet is also moving. It looks like she just turned around. It looks like the clouds are moving as well, although they move really slowly. They look very fluid in this painting. And there's also a lot of light, and it's a very light and bright painting. So this painting is called Woman with a Parasol, Madame Monet and Her Son, and it's all on canvas. And so with all these characteristics, it's clearly a art style of Impressionism, which is defined as an art style with relatively small, thin, yet visible brushstrokes, open composition, emphasis on accurate depiction of light and its changing qualities, ordinary subject matter, inclusion of movement as a crucial element of human perception and experience, and unusual visual angles.
We know that we can split off this given side length into 8 and 8. So if we add up 8 and 9, we get the radius, which will be equal to 17. Now, since this point over here is also a point on the circle, if we draw a line from the midpoint over here to the corner of the square, we know that this has to also equal 17, because that's the radius. So now that we have a triangle over here and we know 2 of the sides, we can just get the third side. If you recognize this as a Pythagorean triplet of 8, 15, 17, you can just write this in. If you don't, then you can just go through the process of the Pythagorean theorem equals c squared. So that's 289 minus about 64 equals c squared. So that will equal to 25 equals c squared. C equals 15. And now you have 15 as this side of the square, and you have 16 as the other side. So what you can do is you can just multiply 16 times 15, which will give you 240 as the area of the square.